Chapter 4, Section 3, dividing polynomials using long division. Later on, we'll use another method called synthetic division. It's two different ways to divide our polynomials. The other day, we talked about adding, subtracting, and multiplying. Now we're talking about dividing. So let's just jump into it. An example. We've got the polynomial x cubed minus x squared minus 2x plus 8 divided by the binomial x minus 1. Wants me to divide these two polynomials. Make sure our laptops are away, please. Thanks. So I'm going to set it up like we did our 4th grade division problems. The first polynomial is going to be my dividend. So it goes under the division symbol. X minus 1 is my divisor, so it goes outside. Everyone okay with that? So I'm doing x cubed minus x squared minus 2x plus 8 divided by x minus 1. Okay? All right. So this is similar to our 4th grade long division. That's why we did that when we came back from break. So the first thing I need to do, I'm asking myself, this first term right here, x times what would get me to x cubed? So x times what would give me x cubed? X squared, right? Because when you multiply something with the same base, you add the exponents. So x to the first times x to the second would give me x to the third, right? So that's going to be the first thing I put up top, is x squared. I'm going to go ahead and put it over my other squared term. So x squared. Okay? Everyone with me so far? When we were doing our 4th grade long division, after I put a number up here, what did I do with that number? Say I've got like 151 divided by 4. I say, how many times is 4 going to 15, right? How many times is 4 going to 15? 3, so I put a 3 there. What do I do with that 3? Multiply by 4. So what do you think I'm going to do with this x squared? Multiply the x squared by this binomial, x minus 1, right? Just like we would over here, okay? So x squared times x gives me x cubed. X squared times negative 1 gives me negative x squared. We okay with that? Okay, so up here I would have done 4 times 3 would give me 12, right? In our normal long division, what do I do with that 15 and 12? Subtract them. I'm going to do the same thing down here. Now we are subtracting the whole polynomial. Do you see how it's matching up to what I've been doing with our long division?
Yeah.
So 15 minus 12 would give me what? 3. Okay. Remember, I'm subtracting this whole binomial. So I have negative x squared minus negative x squared. So it's like negative x squared plus x squared.
Is that thing on the right just for like...
This is to compare. Yeah. This is to compare to what we're doing with our polynomials. Okay? Does that make sense? So if I have negative x squared minus negative x squared. 0x squared, right? Everyone okay with that?
Yeah.
And then x cubed minus x cubed. 0x cubed, right? So that just cancels out. What did I do over here with my normal long division after I subtract?
You pull down the 1.
Bring down the next item, right? So I bring down the 1. So what do you think I have to do over here?
The negative 2x.
Bring down the next term. Negative 2x. We okay with that? Everyone still with me? Okay. So, x times what? I'm now looking at this front term. The first term will always cancel out when we subtract. Okay? I know this one technically canceled out, but I'm going to leave it there for a reason. Okay? So, x times what would give me 0x squared?
X times X.
0x, right? Okay? So, 0x times x we said give us 0x squared. 0x times negative 1 gives me 0x, right? I should have left myself some more room. Say it again.
How do we get?
Whenever we're dividing our polynomials, it's always important that we keep every consecutive term there, even if it's not technically there. If that makes sense. So our highest exponent in this polynomial and our dividend is 3. So I want to make sure I have all the ones below it with it. So 2, 1, 0. So even if I didn't have this x squared term, I would represent it with 0x squared. So that's all I'm essentially doing here. Okay? We'll get to an example like that here in a second. So, subtract. What's negative 2x minus 0x? Negative 2x. And what do I do with that 8? Bring it down. Everyone okay with that? Now I'm asking myself, x times what would give me negative 2x? Negative 2. So, minus 2. Everyone still with me? So we're always just looking at the first term of my divisor, right? And then the rest fills itself in when I multiply. So it's negative 2 times x. Negative 2x. Negative 2 times negative 1. Positive 2. And then what do? Subtract. 8 minus 2. 6. 2x's cancel out. Do I have anything else to bring down?
No.
No. So I have a remainder here.
So decimal.
Right? So let's look over here. How many times is 4 going to 31?
7 times.
7 times, right? 4 times 7.
28.
28. Subtract. 31 minus 28.
3.
What did I do when I had a remainder on my normal division?
You just put
R1.
Make it a mixed number, right? So what would be my answer for this division problem to the right? 37. My remainder becomes the numerator of my fraction. And what's the denominator?
4.
The divisor, right? Same concept for my polynomials. Here is my whole number. So do I need to include the 0x now in my answer? Not in my answer, I don't need to include it. What's my remainder? 6. And this is going to be plus. So 6 is going to be my numerator. What would my denominator be?
X minus 1.
X minus 1. There would be my answer. Does everyone see how it matches up, though, to our normal long division with just numbers?
Yeah.
It still matches up, right? We're doing the same steps. That's why we reviewed that long division at the beginning of this semester. Okay? We are going to do a couple more examples, so hopefully it starts to click a little better. Okay? Yep, up top in the left, boxed in. That's my answer. Whatever we have for a remainder, that becomes my numerator for my next fraction. The divisor is still my denominator. If I get a remainder of 0, am I going to have this?
No.
No. If I got a remainder of 0 here, it would have just been x squared minus 2 is my answer. Okay? Questions about that? Can I move on to the next example? Sweet. X to the fourth plus 2x squared minus x plus 5. Divided by x squared minus x plus 1. So what goes under the division sign? Top or the bottom? Top, because it's the top divided by the bottom, right? So my bottom is going to go outside, so I'm going to go ahead and write that one first. Okay. Earlier I was trying to explain that I need all the consecutive terms. Do I have an x cubed term?
Yes.
Up top? I do not. It goes from x to the fourth to x squared, right? I still need to account for my x cubed term with a 0. So I'm going to put plus 0x cubed. Do I have an x squared term?
Yeah.
Yeah, so I put that one. Do I have an x term?
Yep.
Yep, and then do I have a constant? Yep. So on the outside and on the inside of my division symbol, I want to have all consecutive exponents after my biggest one. Does that make sense? So out here, the biggest one's 2, so I want a term that's just x, and then I want a constant. Inside, my biggest exponent is 4, so I want 3, 2, 1, and a constant also. That makes sense about my exponents. So if you don't have a, like here we didn't have an x to the third term, I still need to account for it with a 0. Me putting that 0 there, did that change anything about my polynomial? No. So it's okay to put it there. It just helps me line everything up correctly. Okay? Okay. So once again, I look at my first term of my divisor, x squared. So I'm asking myself, x squared times what would give me x to the fourth? X squared, right? So I'm going to put that x squared above my x squared term. Does everyone see how we line it up with the same exponent?
Kind of.
Wait, what?
I put it over the x squared term, right?
Wait,
Oh.
X squared, I put it over x squared.
skipping the rest?
Yeah, like.
What do you mean?
Wait, how come x squared can't go in x?
So we're just skipping the rest.
What do you mean skipping the rest?
So like you just skipped over like the other two.
No. Because x squared times x squared gives me x to the fourth, right?
Oh yeah.
This is just how I line it up. Because when I start multiplying here in a little bit, the next term that I multiply by is probably just going to be x to the first power. And the next one's probably just going to be a constant.
You're right.
Okay? So let's see how it plays out. X squared times x squared is
X to the fourth.
x to the fourth. X squared times negative x.
X to the third.
Negative x to the third.
Wait.
Here I'm multiplying this x squared times my divisor. So x squared times x squared gives me x to the fourth. X squared times negative x gives me negative x cubed. X squared times 1 gives me x squared. Right?
How do we get the 1?
The 1?
Oh, that's a 1. I thought it was a parenthesis. I see it.
Okay. Everyone with me on this one so far?
Yeah.
After I multiply that x squared times my divisor, what do? Subtract. Don't forget we're subtracting the whole polynomial. So I have 2x squared minus x squared. What does that give me?
Wait, you said 2x squared minus 2x squared?
2x squared minus x squared.
X squared.
X squared. Positive x squared, right? I have 0x to the third minus negative x to the third.
X to the third.
Positive x to the third, right?
Positive. Wait,
Yeah,
what?
it's minus.
0 minus the negative.
Oh, it's adding.
0 minus, so 0x to the third minus negative x to the third would turn to positive. X to the fourth minus x to the fourth
X
cancels
to the
that.
fourth.
Cancels that.
Okay.
Okay, what's next?
Bring down the negative x.
Bring down minus x. Everyone okay?
Okay, I see.
Now, I'm asking myself, x squared times what would give me x to the third?
X.
X.
X. So I'm going to put a plus x right here.
How does 0x cubed minus... Oh, it's minus negative. Very good.
Yeah, I got
Right.
Yeah, I got me too.
Yeah, you got to keep that in mind with the signs here. We're subtracting this polynomial, so it's 0x cubed minus negative x cubed. You got to pay really close attention to the signs. So, I put an x up top. Now I've got to multiply this x times my divisor. X times x squared. X cubed. X times negative x. Negative x squared. X times 1. X. What do I do with that? Subtract it again. Remember, we're subtracting the whole polynomial. Negative x minus x.
plus X.
Negative x minus x.
Zero.
Negative 2x.
What?
Oh, you meant that one right there. I thought I was seeing the cube.
Negative x minus x, right?
Yeah, I was seeing
Negative
the cube.
2x. Because it's like negative 1 minus 1. X squared minus negative x squared.
2x squared.
Positive 2x squared. Everyone okay with that? X cubed minus x cubed. Bye-bye.
3x cubed.
Nope.
Oh, that's
Cancels out. We're almost done. What do I have to do now?
Bring down the 1. Or
Bring down the 5.
Bring down the 5 plus 5.
How?
Okay. Now, I'm asking myself, x squared times what would give me 2x squared? 2. So I put a plus 2 up top. Does everyone see how the x squared lines up with the x squared? The x lines up with the x. The constant lines up with the constant. Keep them lined up.
Wait, so how did we get that 2?
I asked myself, x squared times what gives me 2x squared? Because that's my new polynomial that I'm looking at.
Oh, so you only have to pay attention to the first one.
Yep, and then everything fills into place when we start multiplying. Okay? So 2 times x squared.
2 times 2x. 2,
2 times x squared.
2x squared.
2x squared. 2 times negative x.
Negative 2x.
Negative 2x. 2 times 1.
2.
2. Subtract. 5 minus 2. 3. Negative 2x minus negative 2x. 0x. 2x squareds, 2x squareds cancel out. Do I have anything else to bring down? No.
Wait,
So-
so why do we do 0x?
That's just in case we needed to continue it out further. Since I don't, I really don't need that 0x. Okay? So what's my answer here?
X squared plus x plus 2 and then 3 over x squared minus x plus 1.
Very good. So up top, that's my whole number, right? X squared plus x plus 2. Then I have to add my remainder. What's my remainder here? 3 over my divisor. What's my divisor?
Squared minus x plus 1.
So here'd be my answer. Everyone okay with that? Pretty fun stuff, huh?
No.
Sure.
Yeah, good stuff. Can I move on to my last example?
Yes.
It's gonna be a rough one.
Divide 2x to the 4th plus 3x to the 3rd plus 5x minus 1 by x squared plus 3x plus 2. So what goes on the outside of the division symbol?
You just had to make. I mean, I can't.
The x squared plus 3x plus 2.
X squared plus 3x plus 2. Do I have all my consecutive terms with that one?
No.
For x squared plus 3x plus 2?
No. Well, yes.
Oh, you mean like, just kidding.
Two.
For this one.
Yeah.
Do I have all the consecutive terms?
Yeah.
What's the biggest exponent?
4.
No. What's the biggest exponent?
2.
2. Do I have an x to the 1 term?
Yeah.
Yep.
Yeah. Do I have a constant?
Yeah.
I got all the consecutive ones there, right?
Another one. I'll say.
Everyone see that?
Yeah.
Yes.
If I didn't, I would have to fill it in with a 0, whatever term I'm missing.
So if you had like an x squared and then it was just a constant, you would have
Yep.
to
So let's just say this was x squared plus 2. I would have to write it as x squared plus 0x plus 2.
Okay.
Does that make sense? But that is not the case here. I have all consecutive terms. X squared plus 3x plus 2. Okay? For my dividend, does that have all the consecutive terms? What's my biggest exponent? 4. Do I have a term with an exponent of 3?
No.
Yeah.
Yes, I do. Do I have a term with an exponent of 2?
No.
No, so I'm going to have to use a 0 to fill in that x squared term. Do I have an exponent of 1?
Yes.
Yes.
Yes. Do I have a constant?
Yes.
Yes, I do. So, 2x to the 4th plus 3x to the 3rd plus what?
0x squared.
0x squared. Got to use that 0 as a placeholder for my x squared term. Plus 5x minus 1. Everyone okay with that? Use a placeholder of 0 if you don't have that term. Okay? Okay. Someone raise your hand and give me my first step. Yes.
See if how many times x squared goes into 2x goes to 4.
Very good. So x squared times what would give me 2x to the 4th?
2x to
Huh?
2x to the second.
2x squared. Where do I put that 2x squared?
Over the
The 0x squared. So 2x squared. Keep it lined up with its like terms. Everyone okay with that? Now I'm going to start multiplying 2x squared through my divisor. X squared plus 3x plus 2. So 2x squared times x squared.
2x squared times 2x squared.
2x squared times x squared.
2x
2x to the 4th, right? 2x squared times 3x.
6x. 6x.
6x to the 3rd. 2x squared times 2.
4x squared.
4x squared. We okay with that? Everyone getting the process down decently well.
I guess.
Subtract. I have 0x squared minus 4x squared.
Negative 4x squared.
Very good. This is why we have to have that placeholder of 0, so we can do our subtraction with our like terms. Okay? 3x to the 3rd minus 6x to the 3rd.
Negative 3.
Negative 3x to the 3rd. 2x to the 4th is canceled.
Is it not like cubed?
It's cubed. Or you can say to the 3rd. Either one will work. Okay, what's next?
Bring down the 5x.
Bring down the 5x. Now, once again, we're looking at the first term of each polynomial. So I'm looking at x squared and negative 3x to the 3rd. So x squared times what would give me negative 3x to the 3rd? Negative 3x. Everyone okay with that? If I multiply x squared times negative 3x, I get negative 3x to the 3rd. So, I'm going to multiply that through. What's negative 3x times x squared? We just said it was negative 3x to the 3rd, right? Yeah. We just said it was negative 3x to the 3rd. X squared times negative 3x.
Oh.
Negative 3x times positive 3x.
Negative 6x squared.
Not 6.
9.
9.
What?
Multiply. Negative 9x squared. Negative 3x times 2. Negative 6x. We okay with that? Subtract. So I have 5x minus negative 6x.
Negative 1.
Positive 11x. Because 5x minus the negative 6 turns to plus. So 5x plus 6x is 11x. Think about your signs. Negative 4x squared minus negative 9x squared. Positive 5x squared. 3x cubes cancel out. Questions there? What's next?
Bring down the negative 1.
Bring down the minus 1. Everyone with me? If you're not paying attention, you're going to get lost. It's going to be confusing if you're not paying attention. It's already confusing enough as it is. So, x squared times what would give me 5x squared?
5.
Times 5, so I put my 5 up here.
Since you're old, do you know how to do this?
And now I can multiply my 5 through my divisor. 5 times x squared. 5x squared. 5 times 3x. 15x. 5 times 2. 10. We okay with that?
Yeah.
Subtract. Negative 1 minus 10.
Negative 1.
Negative 11. Negative 1 minus 10. 11x minus 15x. Negative 4x. 5x squareds cancel out. Do I have anything else to bring down? No. So what's the first part of my answer without the remainder? 2x squared minus 3x plus 5. I'm going to write this somewhere else where I have more room. Tried it up top. 2x squared minus 3x minus 5. Everyone okay with that? That's what I got above my division problem. Plus, what's the numerator of my fraction?
Negative 4x minus 11.
Negative 4x minus 11, my remainder. Over, what's the denominator? X squared plus 3x plus 2, my divisor. So there would be my answer. Do we have a question?
Yeah, that's plus 5. No.
Can you
You
split
are correct.
that very last part to me?
The remainder?
No, the 5x squared plus 11x minus 1.
Okay.
Oh, no, we just got that from subtracting. Never mind.
Yep. We subtracted 5x minus negative 6x,
And
negative
then-
4x squared minus negative 9x squared. Bring down your negative 1. And then I asked myself, x squared times what would give me 5x squared? 5. So now I multiply this through my divisor. Okay?
Yeah.
It's the same process as our normal division with just numbers, right?
Yeah.
It can kind of get a little hairy though with all the variables and the exponents and all that good stuff. Make sure though, you always use your placeholders of 0 if you don't have that consecutive term. On the outside and on the inside. Everyone got it?
Yes, sir.
Questions, comments, concerns? We okay? Here's our assignment.
5
Oh, that's-
problems?
6.
Really?
6 problems.
Heck yeah.
5.
6.
5, 6.
Oh,
What are you looking
You got to count number 5 as well.
Whoa.
Oh.
Yes, you did.
So, page 187, 5 through 10 all. 6 problems of what we just did. Dividing polynomials using long division. We're not in school till next Tuesday, so this won't be due till next Wednesday,
Let's go.
the 19th. Okay? You got a lot of days to do 6 problems. And if you plan it out correctly, you won't even have to do any work on those 5 days, unless you have a lot of missing work. So are there any questions about my notes before I end my recording? So this is due Tuesday. Nope, I said Wednesday. Wednesday, January 19th. On Canvas. I have put some grades in. I've entered in zeros. Some of us haven't turned a single thing in.
Sweet.
So, some of you have a 0 in my class right now. You need to get that fixed. You need to get stuff turned in. Has everyone got it?
Yes, sir.
Okay, any questions before I end the recording?
How's that?
All right.